First lecture, we introduced the general logic of macroeconomic theory, that is, the question determines the method. In the second lecture, we introduced macroeconomic measures to build a bridge between the macroeconomic question and the macroeconomic method. Today, we are going to focus on measures of one of the two fundamental macroeconomic questions, short-run business cycles. To recap, there are two fundamental macroeconomic questions. The first one is economic growth, which discusses changes in the long-run trend. This topic is covered by Chapter 7 and 8 in the textbook. The second one, which is the focus of this lecture, is business cycle, which discusses deviations from the trend. You may wonder why business cycles are so important. Why do we even care? For developed economies like the US, the UK, and the EU, they have slow economic growth because they are already at the frontier of the development of human beings. Therefore, they attempt to minimize business cycles and promote economic stability. However, if you come from developing countries, such as China and India, then economic growth may be more important because fast economic growth can provide greater social mobility, which makes the society less unstable. For policymakers, it is essential to make the right decision in different phases of business cycles. A recession can deteriorate fast to depression if timely interventions are not implemented. Policymakers must be vigilant during recessions because a small spark can lead to a big fire. Think of the Great Depression in 1930s and the Great Recession in 2010s. On the other hand, policymakers also need to keep an eye on booms, which can be irrational bubbles due to animal spirit in the financial market. If bubbles are too big, the burst can be catastrophic. The higher you climb, the worse you fall. For individuals, business cycles are vital investment signals. For example, if the UK is expected to experience a boom, then you should hold a long position of Great Britain pounds or GBP in the trading game that we are going to play next semester. However, if the UK is expected to undergo a recession, then you should place a short position of Great Britain pounds. The best investment during recession is actually human capital or education, because the chance of getting a good job out there is slim anyway. In previous lectures, we defined business cycles as fluctuations about the trend of real GDP. It is usually expressed in the form of percentage deviations. A complete business cycle has a trough and a peak. Interchangeably, they are sometimes called recession and boom, or contraction and expansion. There are some properties of business cycles. The first one is the amplitude or magnitude of business cycles, and the second one is the frequency or duration. Looking at the actual data of business cycles in the US, you can see three obvious features. First, it is choppy and unpredictable. Second, there is no regularity in the amplitude. The recession is sometimes severe and sometimes mild. Third, there is no regularity in the frequency of business cycles. To summarize, to predict business cycles is like to predict the Welsh weather. Recessions can happen anytime, just like rains can drop anytime. You may ask, is there any regularity of business cycles at all? This is what we are going to do in the rest of the lecture. Now we have already achieved two of our learning objectives: why we care about business cycles and what a business cycle is. To summarize the regularity or stylized facts of business cycles, we first need to define two measures, one on co-movements between variables and the other on variability of a single variable. Let's first look at the measurement of co-movements. We have seen that business cycles of GDP per se are very unpredictable in amplitude and frequency. However, we have many other macroeconomic variables changing along business cycles. Can we find any patterns for pairs of variables? The logic is like, of course, we cannot forecast the weather in Cardiff. God knows when it is going to rain. However, if you already know that Bristol is raining, then it is quite likely that Cardiff is raining too. So, there are three possible contemporaneous co-movement between any two variables. The first is pro-cyclical, or just cyclical, which means that the variable is positively correlated with percentage deviations of GDP. For example, wage is usually pro-cyclical. The second is counter-cyclical, which means the variable is negatively correlated with percentage deviations of GDP. For example, unemployment is usually counter-cyclical. And there is a third type, a-cyclical, which means there is no correlation at all between the variable and GDP. For example, the working hours or intensive margin is usually a-cyclical. It does not fluctuate over business cycles. In both booms and recessions, people work 8 hours a day, but the chance of working may vary. To provide intuition, we usually use two ways to present co-movements of two variables. The first is time series plots. The horizontal axis is time, and the vertical axis is the value of variables. The first two plots illustrate a pro-cyclical example and a counter-cyclical example. The second way is scatter plot. The two axes are values of two variables, so the correlation is more straightforward. The first plot is a-cyclical. The second is pro-cyclical because they move in the same direction. The third is counter-cyclical because they move in the opposite direction, so they have a negative slope. Now let's look at how to measure co-movements. For contemporaneous co-movements, we usually use correlation coefficient to quantify the cyclicality. Correlation coefficient ranges from -1 to 1. The sign suggests the direction of co-movement, and the magnitude is the strength of co-movement. So if it is equal to 0, then it is a-cyclical. For example, as shown in the following two plots, percentage deviations of imports and GDP are positively correlated with a correlation coefficient of 0.7, so imports are pro-cyclical. Like rain in Bristol usually occurs later than the rain in Cardiff, there may be lead or lag in timing of the correlation. If the variable neither leads or lags, we call it coincident. Usually, we use the VAR model to estimate the direction and strength of those dynamic effects. Again, note that all cyclicality is defined in terms of GDP. So if a variable leads GDP, we call this variable a leading variable. If it lags behind GDP, then we call it a lagging variable. Here is an example where the black line variable tends to lead the GDP, which is blue. This is how we measure co-movements between the macroeconomic variable and GDP, so that we can define cyclicality. In addition, it is also of interest to measure the variability of a macroeconomic variable on its own. Co-movements describe relationships between two variables, while variability or volatility describe a feature of one single variable. We usually use standard deviation to measure variability. If you're not sure what standard deviation means, you can go back to your A-level maths or read the short course in quants on my website. Note that standard deviation is a univariate measure, because it only concerns one variable at a time, unlike correlation coefficient which pertains to two variables at a time. Also, standard deviation is commensurable because all variables, including GDP, are expressed in percentage deviations from their trends, so they are all comparable. We mentioned two stylized facts on variabilities of business cycles in the first lecture. The first is that the standard deviation of consumption is lower than that of GDP. This is also termed as consumption smoothing. It makes sense because people's income can vary significantly over time, but we do not want our consumption to vary too much. Consumption can be smoothed over time with the help of credit market. You can borrow when the income is low and lend when income is high. The second stylized fact is that the standard deviation of investment is higher than that of GDP. This is termed as speculative overshooting. Just look at the stock market, which is always ups and down, while GDP is relatively stable. This is because investment depends on forward-looking expectations and speculations, which can change more radically than GDP, which is physically produced and cannot change as you want. To now, we focus on quantities in the output market such as consumption and investment. Now let's look at co-movement and variability of other variables. Real GDP, consumption, and investment are real variables because they use constant prices, and changes of these variables are purely due to changes in quantity, not price. But in practice, prices can change too. Note that prices here refer to nominal prices denominated by money. They are not to be confused with the relative prices denominated by the numeraire, which are usually used in microeconomics. In fact, nominal prices are special cases where the numeraire is money. If you look at the time plots of price and GDP, the relationship is quite mixed. Before 1970s, they are pro-cyclical, coincident, and less volatile. After 1970s, however, they are counter-cyclical, coincident, and less volatile. Therefore, it seems to suggest three possibilities of the relationship between prices and real GDP, which is also called the Phillips curve. The earliest version of the Phillips curve is positively sloped, which was found by Phillips in 1950s. However, there can be a reversed Phillips curve after 1970s, which is negatively correlated. In the long run, we can also say that there is no relationship at all between prices and GDP. The vertical Phillips curve is just the classical aggregate supply curve, which is also called the classical dichotomy. It means that the nominal side and the real side of the economy are irrelevant. We will discuss this theorem in the next semester. Up to now, we only discussed stylized facts of the output market, including real GDP and its components and prices. Now let's turn to the input market. The blue lines are GDP and black lines are employment and real wage. According to the time plot on the left, employment is pro-cyclical, lagged behind GDP, and less volatile. On the right, real wage is pro-cyclical, coincident, and less volatile. Note that real wage can be treated as a proxy of productivity, because productivity is defined as output per worker, while wage is income per worker, and on average, the two should be very similar. Now we are going to summarize all the stylized facts on business cycles or the research questions of business cycles by both quantitative measures and qualitative descriptions. This slide summarizes quantitative measures of both co-movements and variability. Recall that Correlation coefficient is a quantitative measure of co-movements between variables, and standard deviation is a quantitative measure of variability. To make better sense, we express standard deviations relative to that of GDP. So if it is less than 100, then it is less volatile than GDP. If it is more than 100, then it is more volatile than GDP. A good macroeconomic model should be able to match all these quantitative features. These figures are based on the US, but the UK and other developed economies share similar magnitude. To make it more generalizable, we re-summarize these quantitative measures in a qualitative way. These stylized facts are the short-run business cycle questions to be answered by economic models in this module. We will start with stylized facts of business cycles in the labor market, which is featured with static decisions. The question determines the method, so we are going to employ static models in the next topic. Please read Chapter 3 of the textbook and try to do the self-test questions on the website. And if you are not sure of standard deviation and correlation coefficient, please use the resources listed here. Have fun!